Okay, let's look into the following. We have to determine dy over dx of the following. Always, before we even differentiate, we need to inspect the functions or the function that we're given. So, first of all, I see a cube root, which underneath is carrying as a difference of functions, the cubic function and a trigonometric function. So, we know it's either if I see square root, it's either I'm going to use what we call power rule. That's the first thing. Then there's what we have to apply again inside power rule, and we see there's still trigonometric function. So we have three rules that we have to apply there. So as we see now, this is a change of functions. As you remember, first of all, cannot derivate there if, let's say, the function is still in a root form. We need to make sure it's in power, in exponential form. So if we do so, we're going to have x cubed minus sine 3x. And we know that changing that to an exponential format is going to be 1/3. So it's a cube root, therefore in exponential format, it's 1/3. Now, if everything is in standard form, that you can simplify in terms of we can change the function. If you remember, on Friday we said that, I hope you see, we see a function is inside what? An nth bracket to the power of what? 1/3 bracket. So which means we have to apply power rule accordingly and derivate what is inside after. So we know derivative of that is going to be dy over dx, which is going to be equals to 1/3. Therefore, inside the function sine 3x, we need to subtract 1 to the exponent, so it's going to be, so it's minus 2/3. So we are not done. We need to multiply by the derivative of, the space is small here. So please allow, I want to multiply, put a multiplication here. Okay, it's fine. Let me just overlap. So we are going to multiply now by the derivative of what is inside the bracket. That is change of functions. So multiplication derivative of x cubed is 3x squared. Therefore, minus derivative of sine 3x. It's going to be cosine of the same angle. And we need to multiply by the derivative of the angle, derivative of 3x, which is 3. Then we can close shop. So we have our f of x inside the bracket, and it's f prime of x. It's there. So 3x squared minus 3 cos 3x. Now, what is left is to simplify. So when we simplify, this will be in the numerator, but if you want, I see there's a common factor there. So I can take out a common factor of 3. In the meantime, so as I said, we have x squared minus, it's taken out the common factor, we have 3 cos 3x. So we're taking a common factor here, then all divided by. So you'll agree with me that this is a negative exponent. We need to take it to the denominator. It changes the exponent and becomes positive. So it meets with 3 then the denominator. So changing into exponent into denominator, we need to change to root form. So we're going to have cube root of this. Okay, let me not skip this, but in N5, we're not expecting to show this step. We know taking this to the denominator changes the exponent and becomes positive 2/3. And we can change, we know that our root is a cube root, then the exponent is 2. So we can leave it in this format. So the final answer, normally you'll see it as x squared minus cos 3x, because 3 divided 3 there. Then all divided by cube root of, so that's cube root. Whatever is inside, it is x cubed minus sine 3x, all in all to the power of what? To the power of 2. So you can still change into exponential format, or you leave it in exponential format to say, or in root 4. So that is the homework you have. So the chains of functions in N5 is very important. You won't run away from. That's the final answer. So if, for an example, you're in integration, we say now integrate the following. So normally they will be given in this form. So you'll know that, oh, I'm inspecting this denominator, gave me this numerator. And if let's say I express this and then to exponential format, you'll see that this, if you derivate this, you get this. So you know that, oh, this was the function, this is the derivative. So we know the whole of the natural logarithm is to the power of 3. So it's not just the sine, in fact, it's not sine cos cot to the power of 3, it's the whole of natural logarithm. So when we derivate, we know this change of functions here. So we start from outside and going inside. So I still see a power rule. I can let everything inside that bracket to be u. But in differentiation, I don't emphasize on u method. We need it in integration here. Don't waste time. So, but I know this, it's to the power of 3. So not wasting time as long as everything is fully simplified out. I know the derivative, I'm going to say 3. And therefore, lean to the power of what? Subtract 1. So we're going to have what? 2. And therefore, still the same function inside the logarithm. Now we need to multiply by the derivative of what is inside the natural logarithmic function. So inside the thing, or let me say this, inside the, because lean is underneath the bracket to the power of 3. So make sure you treat it in this way. So now derivative of a natural logarithm, we know it's going to be 1 over. So it's 1 over sine x minus cot x. But the rule says what? You must even derivate what? What is inside the function. In the numerator, we multiply by the derivative of sine, which is cos x. Therefore, minus derivative of cot x is, so it's supposed to be minus cosec cot. Did I say cosec squared to say? So this will be positive. Now cosec squared x, the numerator. We are done. So derivative of ln x is 1 over the function, and in the numerator multiplied by the derivative of the function inside the log function. We are done. So the rest, I don't think there's something anything you can do there to simplify. You can leave it as it is. As 3 ln squared sine x cot x. Then multiply by cos x plus cos x squared over sine x minus cot x. Okay. I hope you got something like that when you're doing the problem at home. Did you get that? Or you didn't try it? Hmm? So that's how we're supposed to get it. So please make sure, for you as a student, I'll always advise you to do this. As much as you see it was lean cute, make sure you know it's the whole of the natural logarithmic to the power of 3. If it's cos squared, please know it's cos in bracket to the power of 2. As a student, I will always advise you to do that because you can make a mistake here when you want to derivate. Yeah. So first of all, I see we have how many functions? We have 3. So we have an exponential function and a trigonometric function in the numerator. But 2, we have in the denominator another, can I say algebraic function? And again, it's underneath the bracket. Means there will be close to 4 rules will apply because I'm saying, first of all, when I see division, the mind rings quotient rule. That's the first thing. Number 2, hallelujah. Number 2, we see product rule there, isn't it? So which means we'll apply product rule when we derivate the numerator and when we see the denominator. There is a quotient of 2 functions, isn't it? So the first thing that we're going to do, according to quotient rule, dy over dx is going to be equals to, the rule says that you must square what? We must square what? We must square what? The denominator. So it's x squared plus 1. So let us square 2 there. Or let me write it in this way, square, right? So let's square that denominator in that way. That's the first thing. Number 2, we need to derivate the numerator. That's the rule, isn't it? We multiply by the derivative of the numerator in the first term. So let's okay. So we look into the numerator. It's a product of two functions, and we have to derivate that numerator. So we'll apply product rule. So that's how I said it was interesting. So we know that, when we have to derivate the numerator, there's product rule that we have to apply. So it means that according to product rule again, we need to multiply by the derivative of the first function, it's e to the power of x. And now multiply now by the second function, cos 2x, plus the second term. We have to multiply now by the first function and multiply by the derivative of cos 2x, isn't it? So derivative of okay. Sharp cousin. Sorry about that. So we derivated e to the power of x multiplied by cos 2x plus second term will multiply by e to the power of x. Now derivate cos 2x. So it's going to be negative sine 2x multiplied by the derivative of the angle, which I did there, which is 2. Close my v bracket. Therefore, plus. In the did I say plus? I must say minus. I get where in quotient, so minus. So here I was just derivating this, and I'm forgetting to multiply by the denominator, isn't it? So we need to multiply by the denominator, which is x squared plus 1, all in all to the power of 2. Therefore, we can say minus, because this is the derivative of the numerator multiplied by the denominator. So in the second term now, as we are using quotient rule, we are going to now we're going to derivate the denominator and multiply by the numerator. So it doesn't matter if you start by multiplying and derivate, either way, as long as you're having multiplication. So I can start by multiplying by the numerator, which is e to the power of 2, e to the power of x cos 2x. And we need to multiply now by the derivative of the denominator. So derivative of the denominator gives us the chains of functions. So it's chains of functions. Or if you wanted, you should have multiplied it out and have x to the power of 4 2x squared plus 1, and then derivate. But if you use chains of functions, we're going to derivate and have derivative, as I said, is 2 to multiply by 2 and subtract 1. And we need to multiply by the derivative of what is inside the bracket. Derivative of x squared plus 1, which is 2, which is 2x. Then 1 is 0. If you have done that, no, total mark. If let's say they said simplification not required, you were done. So if let's say maybe you wanted to to simplify out, I think you can multiply out this bracket. And let me see if we multiply out. But this is a longer route. It's not necessary. Okay, if I multiply by that, I'm going to have e to the power of x cos 2x bracket x squared plus 1 to the power of 2. This multiplies that, I'll have negative 2 e to the power of x sine 2x multiplied by x squared plus 1 all in all to the power of 2. Then the last term there, I think is negative 2x e to the power of x cos 2x in bracket x squared plus 1, all divided by. So this is the bracket, taking out the bracket, the exponent multiply each other, you're going to have x squared plus 1, all in all to the power of 4, because 2 times 2 is done. So we'll have that. But if you want to take it further, it's only to factor out, only you can take out common factor of e to the power of x and bracket of x squared plus 1 and 2x cos 2x.